So our polynomial x to the fourth minus 6x to the third minus 4x squared plus 54x minus 45. Let's look for a GCF. Now, if we're using our brains and thinking super hard, at first glance, it should be pretty obvious that the GCF is 1. A good way to find the GCF really quick is finding the smallest number, and in this polynomial, the smallest number is the 1 that's in front of the x to the 4th. Remember, we could write this as 1x to the 4th minus 6x to the 3rd minus 4x squared plus 54x minus 45, and you can see that when I start writing down all of my factors, right off the bat, the only factors of 1 are 1 and 1. If this happens, do I have to go fill out all the rest? No. The smallest number is 1. Its only factors are 1, so the only number they could all have in common is 1. The GCF is just 1. So GCF equals 1. Now we also can't take out any x's, can we? Can we take an x from everything? No, so GCF is just 1. Now, do I have to divide everything by 1 and put the 1 out front? No. When I divide by 1, the polynomial stays the same, so we can just continue on to step 2. And you might be like, why do we even do that? Well, if there was a GCF, we would make the rest of the problem shorter, quicker, easier, less places to make mistakes. So it's good to just check for it at the beginning. Yesterday's problem did have the GCF that we divided out. Today, we don't have one. So we're on to step 2. Step 2, now that we've checked for a GCF, is all revolved around let's start factoring. So we are given our polynomial. We're given our polynomial, and we're given one of its factors. And we know that if x minus 5 is a factor, then when I do long division, I should get a remainder of 0, right? If they're telling us x minus 5 is a factor of the polynomial, then that means it perfectly can be divided out, so I should get a remainder of 0. If I'm not getting a remainder of 0, something went wrong. So let's set up long division. X minus 5, and let's write our polynomial. 1x to the 4th minus 6x to the 3rd minus 4x squared plus 54x minus 45. So go ahead and get your long division set up. Put your little blob above the first term so we make sure we're putting our terms in the right spots. And also add 1 in front of this x, if that helps you. And now we will just begin to do our long division. So, long division is 3 steps repeated over and over again until we reach the end of our polynomial. We always start by dividing our front terms. 1 divided by 1 is 1. We put it up front, or up top, and we match our variables, x to the 3rd. Once we have that top number, we're going to do some multiplication. So we divide, multiply. Okay, so 1 times 1 is 1. Match your variable. And 1 times negative 5 is negative 5. And I'm going to match my x to the 3rds. Divide. Multiply. Now we subtract. Subtraction is where we see the most common student mistake is just incorrectly subtracting. 1 minus 1 is 0. Those first terms should cancel. And we're going to be very careful. This is negative 6 minus a negative 5. So we're subtracting a negative. So in your calculators, you would type negative 6 minus negative 5, and you would get negative 1 x to the third. Subtracting a negative. Okay, bring down your next term. Minus 4x squared. And we are going to repeat these steps again. Divide your front terms. Negative 1 divided by 1 is negative 1. Match your variable and multiply. Negative 1 times 1, negative 1. Negative 1 times negative 5, positive 5. Match your variables and subtract. First term is gone. Negative 4 minus 5 is negative 9. X squared, bring down the next one. Plus 54x. Okay, see how we're just repeating every step until we reach the end. Division, negative 9 divided by 1 is negative 9. We put it up top. And we multiply. Negative 9 times 1, negative 9. Negative 9 times negative 5, positive 45. Once again, subtract. First term is gone, and we be extra careful on subtraction. 54 minus 45 is 9. One more time, we still have this 45, negative 45 to drop. And we're back to dividing our front terms. 9 divided by 1 is a positive 9. Now we take that 9 and we begin multiplying. 9 times 1, 9x. 9 times negative 5 is our negative 45. We have two of the exact same terms, so when we subtract, we get a remainder of 0. Our GCF was 1. We use the given factor to perform polynomial long division.
Good morning, staff and students. Today we are testing for the biology exam. Teachers, please review your list. Send any student that is scheduled to test to their designated testing locations. Again, today we are testing in the area of biology. Thank you so much and have a great day.
At the end of each step, it is important to keep track of where your polynomial's at. We were given it in this yellow form, the full polynomial in standard form, but we have now begun to factor. So right now, after dividing, we have split our polynomial up into a factor and its leftovers. So right now, our polynomial looks like this. X minus 5, that's our factor that was given to us. And we're left with what's on top. 1x to the third minus 1x squared minus 9x plus 9. Here is what our polynomial looks like at the end of step 2. And here's where it's slightly different from yesterday. Yesterday, our leftover polynomial had 3 terms, so we used the x method. Today, our polynomial has 4 terms. So we can't use the x method, and instead we will use grouping. Questions on that second step? Any questions? Okie dokie. Step 3 and 4. So here's what we have right now. We are going to continue to break this polynomial down until we can no longer factor anything. So I've highlighted in green what we can still continue to factor. Since it has 4 terms, we are going to factor by grouping. I'm going to take my polynomial, and I'm going to group it into 2 parts. 1x to the third minus 1x squared is group 1. Group 2 is negative 9x plus 9. That's group 2. Remember, for grouping, all we're doing is taking out our greatest common factor and then reorganizing all of our terms. If we look at our first group, our factors for 1 and 1 is just 1. X to the third means there are 3 x's. X squared means there are 2 x's. So in my first group, my greatest common factor is going to be 1x squared. 1, take away 2 x's. So the GCF is 1x squared. For my second group, I have the factors 1 and 9, 3 and 3, 1 and 9, 3 and 3. Negative 9x has a single x, so my greatest common factor is going to be just 9. However, I have to be very careful because whenever the front term in a group is negative, my GCF isn't positive 9, but instead will be negative 9. Once you have your greatest common factors, we're going to put them out front of our groups and divide. So I'm going to put my 1x squared in front, and I'm going to divide each term by 1 and take away 2 of its x's. 1 divided by 1 is 1. Take 2 x's away, you're left with 1. 1x. Negative 1x squared divided by 1 is negative 1. I took both x's away, so I'm left with 1x minus 1, or just x minus 1. In my second group, we're dividing by negative 9, so we're putting that out front. It's the greatest common factor. Negative 9 divided by 9 is positive 1. We still have that x. 9 divided by negative 9 is negative 1. So 1x minus 1, and our 2 factors match. All we need to do is reorganize this. We see our 1 factor that matches, so that's going to be one of our factors. 1x minus 1, or just x minus 1. And then I also have 1x squared minus 9. And we can't forget, in the beginning of the problem, I was given another factor. That factor is x minus 5. So this is what my polynomial looks like, completely factored. 1x minus 1, 1x squared minus 9, and x minus 5. And for simplicity's sake, we don't even need to have these 1's in front. And this is our factored form. Okay, that's steps 3 and step 4, writing down our fully factored polynomial. Now, what we learned on Monday and Tuesday was if you're given factored form, it is really easy to graph a polynomial. Step 5, we are using what's called the zero product property, and that means any factor that becomes a 0 will multiply our entire function by 0, giving us a solution. So we're going to solve 3 baby mini equations. Now you might need to read out the factors to me. Okay, so factored form. Right now, what do we have? X minus 1, x squared minus 9, and x minus 5, right? It came from our GCF that we pulled out. So here's what factored form looks like. To find our solutions, we set each one equal to 0 and solve a baby equation. X minus 1 equals 0. That's our first equation. X squared minus 9 equals 0. That's our second. X minus 5 equals 0. That is our third. We're going to solve each one for their solutions. Okay, solving our first equation, what do we do to both sides? Easy peasy.
Subtract or add.
We have a minus 1, and the opposite of minus is
Adding.
adding. So I add 1 to both sides. Those minus 1 plus 1 is 0, leaving us with x equals 0 plus 1, which is 1. There's our first solution. Now I'm going to skip to the third one. I'm going to come back to the middle one last. Okay, x minus 5. We draw our waterfall. We need x by itself. We have a minus 5. So I'm going to use the opposite operation. And the opposite of subtraction is addition. So we need to add 5. And the reason we're doing that is if I have a negative 5 and I add 5 to it, what's left over? Nothing. Negative 5 plus 5 is 0. That's why we get to cross it off. We're left with x equals 0 plus 5, which is 5. There's our second solution. Now the middle one is just a little tricky. We have x squared minus 9 equals 0. We need to figure out what x equals. So first, I'm going to start off similar. I'm going to add 9 to the other side, because the opposite of subtracting a 9 is adding a 9. Our 9's go bye-bye, and we're left with x squared equals positive 9. Now, I don't want to know what x squared equals. I want to know what x is equal to. Who remembers from first quarter how we undo an x squared? We can't divide. The opposite of a second power is a root. Specifically, a second root or a square root. We need to take the square root of both sides. The square root of something squared is just itself, so just x.
And 3.
The square root of 9 is not just 3, it's also, when we take the square root, do you remember what that symbol is? Both a positive and a negative. So not just positive 3, but also negative 3. These are our 4 solutions. Positive 1, positive 3, negative 3, and 5. We use these solutions directly on our graph in order to sketch our polynomial. So 1, 3, negative 3, and 5. Take a second, get it down. We will move on to our coordinate plane. So sketching our polynomial. The first thing we're going to always do is identify the x-axis. Here it is, the one going left to right. And we are going to plot our solutions on the x-axis. So we don't need to go up or down, we're just going to plot right on the x-axis. Our first solution we found was what? 1. So we start in the middle, go over to positive 1. Our next solutions were positive 3 and negative 3. So I'm going to go over 3 to the right and over 3 to the left. There's positive 3 and negative 3. And last but not least is positive 5. I'm going to count over 5. Thank you. Over 5. Okay, so this is what we're looking at. Now we need to figure out what direction does our graph go on the left and right side, and then we need to draw our squiggles. This is all done by looking at the first term. You only care about the largest exponent and the number in the very, very front. The degree is the largest exponent. And in this problem, what is our degree? 4. And we're just going to make note that 4 is an even number. Then we're going to look at the number at the very front, the line leader. The line leader in front of this x is a 1. This is called our leading number. Our lead number is 1, and we wanted to make a note and figure out, is that a positive or negative number? In this case, it is positive. So we have an even function with a positive leading number. So we look at that half sheet from Monday, and we look at the top, and we look at even degree, positive a value. So we know that both sides of our function point up. So on both sides of our function, we are going to draw up arrows. On the left side, our function points up. And on the right side, our function points up. Now all we need to do is draw some squiggles, and we'll have our sketch. Remember, if you're struggling with the shape of the graph, if you look at the bottom row of that cheat sheet, it will give you an example of a 4th degree polynomial. So when we're drawing, we start at our left arrow, we go down through the point, and we make a U-turn. Through the next point, U-turn. Through the next point, U-turn. Through our last point and up to our final arrow. How far up and down you make your U-turns does not matter, since it's just a sketch, and there we are done with our example. We have taken that polynomial, factored it, found its solutions, and graphed it using that cheat sheet. All of our skills have come together